Waiting for mortgage rates to drop could be a costly mistake. Once rates drop, new homebuyers will enter the market and prices will soar even higher. At Churchill Mortgage, you can get a free analysis and learn how to avoid the trap of waiting for interest rates to drop. Buy now and refi later at churchillmortgage.com. This is a paid advertisement. NMLS ID 1591, NMLSconsumeraccess.org, Equal Housing Lender, 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027. So you've found the perfect home, but high mortgage rates have you second guessing. The Churchill Mortgage team says waiting to buy can be a costly mistake. Try their free 15-minute analysis to see the difference between buying now versus waiting for lower rates. Visit churchillmortgage.com to learn a smarter way to build wealth through home ownership. This is a paid advertisement. NMLS ID 1591, NMLSconsumeraccess.org, Equal Housing Lender, 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027.
This is SpaceTime, Series 23, Episode 126, full broadcast on the 25th of November 2020. Coming up on SpaceTime, measuring the rotation of the Milky Way central black hole, scientists discovered that the Jovian ice moon Europa glows in the dark, and the European Space Agency sets up an independent board of inquiry into the latest launch failure of a Vega rocket. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
Astronomers have for the first time measured the rotational spin of the supermassive black hole at the centre of the Milky Way galaxy. Located some 27,000 light-years away, the monstrous black hole known as Sagittarius A star has some 4.3 million times the mass of the Sun. But until now, no one's been able to determine its spin rate. Spin and mass are the only two figures that can be used to characterize black holes, objects often simply described as infinite density in zero volume. The new findings, reported in the astrophysical journal Letters, surprisingly show that Sagittarius A star is rotating far more slowly than expected. One of the study's authors, Avi Loeb from the Harvard Center for Astrophysics, says supermassive black holes are crucial for the formation and evolution of galaxies. They release huge amounts of energy which can remove gas from galaxies, and therefore shaping their star formation history. The mass of a central black hole has a crucial influence on its host galaxy, but measuring the influence of the central black hole's spin on its host galaxy is more difficult. To get a better understanding of how Sagittarius A star has impacted the formation and evolution of the Milky Way, Loeb and colleagues instead studied the stellar orbits and spatial distribution of the closest stars orbiting around the supermassive black hole, objects simply known as S-stars. These stars are orbiting the black hole at up to several percent the speed of light, which constrains and places limits on the spin of the central black hole. The S-stars also appear to be organized in two preferred orbital planes. And that's significant because if Sagittarius A star had a significant spin rate, that would have affected the preferred orbital planes of these stars, causing them to be misaligned by now, which hasn't happened. And that's allowed the authors to determine that Sagittarius A star must be spinning only very slowly. Loeb says the S-star data suggests the spin of Sagittarius A star is probably less than 10% the speed of light. The study also points to another important detail about Sagittarius A star, namely that it's unlikely to be generating any jets shooting out perpendicular to the spin. Loeb says jets are thought to be powered by spinning black holes, which act as giant flywheels. And indeed, there is no evidence of jet activity in Sagittarius A star. All this can have major implications for the future detectability of activity at the centre of our galaxy, and also the future observations now planned for the Event Horizon Telescope. This is Space Time. Still to come, evidence that the Jovian ice moon Europa glows in the dark, and the European Space Agency have set up an independent board of inquiry into the latest launch failure of a Vega rocket. All that and more still to come on Space Time. Scientists have discovered that the Jovian ice moon Europa doesn't just shine in reflected sunlight, but it actually glows in the dark. New research by scientists at NASA's Jet Propulsion Laboratory in Pasadena, California, shows that the relentless bombardment of electrons and other particles from Jupiter isn't just pummeling the moon's surface, bathing it in high-energy radiation, it may also be doing something otherworldly, making Europa glow in the dark. The discovery could provide astronomers with new details about the composition of ices on Europa's surface. Scientists base their findings on earlier observations suggesting that Europa's surface is most likely composed of a mixture of ices commonly known as salts, such as magnesium sulfate or Epsom salts and sodium chloride or table salts. It seems different salty compounds would react differently to the radiation and therefore emit their own unique glimmer. To the naked eye, this glow would sometimes look slightly greenish, sometimes slightly blue or white, and vary in degrees of brightness, depending on what material it is. To reach their conclusions, scientists used a spectrometer to separate light into different wavelengths and then connect distinct signatures or spectra to different compositions of ice. Most observations using a spectrometer on a moon like Europa are taken using reflected sunlight on the moon's daytime side. But these new results, reported in the journal Nature Astronomy, infer what Europa would look like in the dark. And the new research shows that incorporating these salts into water ice under Europa-like conditions and then blasting it with radiation does indeed produce a glow. The shine's actually caused by energetic electrons penetrating the surface and then energizing the molecules underneath. When those molecules relax or return to their ground state, they release energy in the form of visible light. And the glow was indeed different depending on which chemicals were used to create the ices. The new findings will help scientists developing NASA's Europa Clipper mission, which is slated to launch in the mid-2020s bound for the Jovian ice moon. This flagship mission will study the moon's surface during multiple flybys while orbiting Jupiter. Mission scientists are already reviewing the new findings to evaluate if the glow would be detectable by the spacecraft's science instruments. It's possible that information gathered by the Europa Clipper could be matched with measurements from this new research in order to identify the salty components of the moon's surface, or at least narrow down what they might be. This is SpaceTime. Still to come, the European Space Agency have set up an independent board of inquiry into the latest failure of a Vega rocket. And later in the science report, new evidence shows that one of planet Earth's greatest mass extinction events was most likely caused by a spate of huge volcanic eruptions. All that and more still to come on SpaceTime.
You're so coy, alluring, angel with a wicked smile, sleeping 20 hours a day, never lay a paw on dusty clay. I'll keep your litter natural, no chemicals in your nostrils, just corn below, so every time you go you'll know your don't stink. World's best cat litter for the world's best cat.
The European Space Agency have set up an independent board of inquiry into the latest failure of a Vega rocket. Arianespace mission V17 suddenly lost control and deviated off its flight trajectory 8 minutes after liftoff. The incident happened as the Avum fourth stage of the rocket was ignited to complete the launch vehicle's ascent to orbit. The mission from the European Space Agency's Kourou spaceport in French Guiana was carrying 2 scientific satellites. The 30-metre-tall four-stage launch vehicle's primary payload was the Spanish SEO-SAT Ingenio high-resolution Earth imaging satellite, designed to study the planet's land cover. Also on board was the French Taranis microsatellite, which was designed to observe luminous radiative and electromagnetic phenomena such as sprites and elves, occurring at altitudes of 20 to 100 kilometres above thunderstorms. The mission had gone smoothly during the first 3 stages of the flight.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80 et décollage Vega 17, Ceosat Ingenio et Taranis. Propulsion est nominale. Tous les paramètres à bord sont normaux. Acquisition de la télémesure pour la station de Saint-Jean.
And they are off. Ceosat Ingenio and Taranis are on their way. Vega flight number 17 is blazing a trail towards space over the night skies of the Amazon rainforest. And the range operations manager is telling us that everything is going well and according to plan. We've broken the sound barrier, haven't we, Damien?
Exactly. After 30 seconds of flight, the launcher velocity gets above the velocity of the sound, Mach 1.
And the job of the first 3 stages is to get us away from the Earth.
Exactly, we take advantage of all the energy of the propellants that are stored on the 3 first boosters in order to get away from the Earth's gravity as fast as we can.
This is the separation of the P80, the first stage.
Exactly.
Et allumage Zefiro 23.
The confirmation has been given that the second stage was ignited and everything is nominal. Yeah.
And this is the beginning of the dogleg maneuver.
Tous les paramètres à bord sont normaux.
Yes, the dogleg maneuver is a change of the trajectory plane of the launcher that we perform just after the separation of P80, and we name it dogleg because when you see the shape of the trajectory, it's like a dogleg.
The Z is for Zefiro, which is actually the name of a wind, isn't it?
It's the name of a wind, and it's also the name of a Greek god, the god of west wind.
Par la station de Galio.
So the fairing, the top of the launch vehicle, and it's protecting our satellites from the rigors of the launch.
Yes, the fairing protects the satellite in different phases. First, during the ground phase, it allows the cavity in which the spacecraft are located to be monitored in specific temperatures. And during launch, first at liftoff, it protects them from the acoustic noise. And during the atmospheric flight, as we go very quickly through the atmospheres, it generates friction, and so it generates heat. And the fairing protects the satellite from this additional temperature.
And those acoustic vibrations at launch are very loud, you can just imagine. So here we have separation now, that's what it looks like, of the next stage.
Yes, we had the separation of the second stage and the ignition of the
Allumage
third.
Zefiro 9.
And there we go. The fairing has now been jettisoned. And we have the confirmations there from the range operations manager. And the launcher is operated remotely, isn't it?
Exactly. And we got information because the launcher sends some signals towards the ground station network that are located around the flight path and that allows us to follow the current status of the flight.
Tell us about those tracking facilities.
Yes, we have several ground stations that are located all over the flight path. The 2 first ones are located in Guyana with Galio and Saint-Jean-du-Maroni, which allows us to follow the booster phases. Then we will be in direct visibility of Bermuda, which will allow us to cover the beginning of the first Avum boost, and Saint-Hubert in Canada covers the end of the first Avum boost. The intervisibility periods between 2 stations are not always interleaved. This is what we call a telemetry hole, and this is something completely nominal because it occurs in a phase where we have no active phases from the launchers, and we have such foreseen hole between Saint-Hubert and New Norcia in Australia for this flight. From New Norcia, we will follow the second Avum boost and the separation of Ceosat. Just after New Norcia, we have once again a telemetry gap as the launchers moves around the Earth. This second telemetry gap will reach its end when we will be in direct visibility from Galio again, located in French Guiana. From Galio, the launcher will send again the telemetry data that is transmitted back to CSG in real time for the main parameters and deferred time for the parameters that are to be studied after flight. We have a slight telemetry hole before being again in visibility from Bermuda and from Saint-Hubert, where we will complete the mission from the launcher.
Okay, so we are now 6 minutes and 17 seconds into our flight. We are traveling at a speed of nearly 8 kilometers per second, which is just phenomenal, really, when you think about it. He's telling us that everything is going well. And we have separation there of the Z9. And we're really entering the next phase now. The main propulsion phase of the launch is over. We're going into the next phase of the flight, which is to deliver our satellites. I believe we're getting ready to pick up the signal in Bermuda.
Yes, we are currently getting the signal from Bermuda. And Bermuda is located in the Caribbean island. And this station is a kind of historical because it was already involved on Mercury programs for NASA and also in the Apollo lunar program. So it's it's a kind of historical location for space.
Tell us about our orbits. Where are we? Where is the Avum upper stage going to take?
As we are on a mission where Earth observation is of utmost importance, we will inject our two satellites onto an orbit that we call...
Sorry, I just heard there we had acquisition in Bermuda while we were talking. Sorry to interrupt you.
So we will inject them onto sun-synchronous orbits. This is a kind of orbits where the satellite passes over the same point of Earth always at the same time. And this is why these kind of orbits are very important for Earth observation, because you have always the same illumination from the sun.
So we're coming up to the next point now, which is the switching on of the Avum upper stage. I call it Avum in English, and of course the French call it Avum. It's the taxi driver. It delivers our satellites to their drop-off points in space, and
La propulsion est nominale.
It's really the next phase of the journey now, isn't it?
And now Avum has taken the wheel, if we can say, so it will propel our launch vehicle with the satellite up to their injection orbit. So for this mission, we will have two boosts before separating Ceosat and two other boosts before releasing Taranis.
Trajectoire dégradée à partir du premier boost Avum.
We are getting information from the Guyana Space Center that the trajectory is degraded on the launcher trajectory. So we're going to wait for information now, more information from the Guyana Space Center. So while we wait, I just wanted to ask you, Damien, what is the sort of normal sequence of events in a situation like this? Because I'm guessing that the people will have to be doing all sorts of analysis and trying to find out what's happening.
At that moment, I think that the team are probably gathering all the available data in order to get an understanding of what's going on. And then we will wait for further information from Guyana Space Center.
And of course, the Guyana Space Center will come back to us as soon as they can bring us more information. And I think in the meantime, we will again point you...
Poursuite des activités BLA au profit de VV17, en attente d'informations complémentaires sur la situation bord. Que tous les moyens restent configurés.
Can you translate that for us, Damien?
It was a message from the range operation manager that was stating that from the ground side, all the operations are going on. It means that all the equipments are in waiting mode for a new analysis or new data coming from the launch vehicle side, and that they remain in a waiting mode, waiting for additional information coming from the launcher or additional acquisition coming from other means.
I'm just hearing in my ear that we're hoping to hear from Stefan Israel shortly, the CEO of Arianespace. Here he is. Hi, Stefan.
Yes, hello, Cathy.
Hi, Stefan. What's the latest?
Yes, so unfortunately, after nominal liftoff and after good ignition and separation of the three first stage and engines, we have observed a deviation of the trajectory after the ignition of the Avum. So this deviation of trajectory is an anomaly. The altitude and the speed were not nominal, and we need now to wait for a new NORSA station acquisition to have more information to communicate on the final outcome of the mission. But for sure, this is an anomaly, and we now need to gather and to consolidate more information before coming back to you.
Okay, so that's the latest news then. Some minutes into the flight after liftoff, we heard that the launcher had deviated from its trajectory. We've been waiting for more information from the Guyana Space Center and for hoping that the new North Sea tracking station might pick up the signal. We are now going to go over to the CEO of Arianespace, Stefan Israel. Stefan, have you got any news for us?
Yes, Cathy, we have some news, and unfortunately they are not good. We can now confirm that the mission is lost. So I remind you what we have observed 8 minutes after the liftoff and immediately after the ignition of the engine of the fourth stage of Vega, the Avum stage, we have observed a degradation of the trajectory. It means that the speed was not nominal anymore. So we have observed this degradation. We need a little more time to understand the next steps, and after the fact that we have had not the acquisition information from the Galileo station, telemetry station, we can unfortunately confirm that the mission is lost. And we have now to analyze, to understand. Our experts are now consolidating the data they have.
Initial investigations indicate that a problem related to wrongly installed cables in a system activating the fourth stage of thruster system was the most likely cause of the failure. Mission managers say that brings it down to a problem of quality control, and therefore a series of human errors. The failure happened just 2.5 months after Vega's return to flight status. Vega suffered its last launch failure back on July the 11th, 2019, when the United Arab Emirates Armed Forces Falcon I-2 reconnaissance satellite was lost, possibly due to a thermal protection design flaw on the second stage's forward dome area. This is SpaceTime.
Preparing for what comes next is a big part of becoming an adult. So, if your teenager says they want to join the military, they're preparing for a real challenge. Visit todaysmilitary.com because their success tomorrow begins with your support today.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that sexual activity and dating app use has declined among Australian adults during the COVID-19 coronavirus lockdown. However, the findings, reported in the journal Sexually Transmitted Infections, also found that chatting on dating apps has increased over the same period. The research by the University of Melbourne looked at the impact of the lockdown restrictions on sexual practices both before and during the lockdown. The study ran during the months of April and May, with 965 respondents, mostly aged under 30, and recruited by way of social media. The COVID-19 coronavirus has now killed almost 1.5 million people and infected some 57 million others since first spreading out of Wuhan, China, a year ago. Scientists have developed a neuron-growing ink that uses the body's own electrical signals to precisely guide the growth of nerve cells. The findings, reported in the journal RSC Advances, claims the bioconductive ink can be printed in lines to direct neurons where to grow, previously a major barrier in the emerging field of nerve engineering. Concentrating the growth of nerve cells in precisely ordered lines is essential to be able to reconnect nerves and heal traumatic nerve injuries. Scientists have also tested the new ink on a biocompatible scaffold with promising lab results. A new study has added further weight to the hypothesis that one of planet Earth's greatest mass extinction events was actually caused by a spate of huge volcanic eruptions. The Triassic-Jurassic or End-Triassic mass extinction event marks the boundary between the Triassic and Jurassic periods some 201.3 million years ago. It saw a major change in the type of life that dominated the planet, including the disappearance of some 34% of marine species, a major turnover of plant life, and the rise of the dinosaurs from a minor inhabitant to one that dominated the planet. But debate has remained over the exact cause of the event. Now, scientists at Curtin University studying molecular fossil biomarkers have found strong evidence supporting the hypothesis that the extinction event was caused by a spate of massive volcanic eruptions in what's known as the Central Atlantic Magmatic Province, pumping huge amounts of carbon dioxide into the atmosphere, inducing profound global warming and ocean acidification. The Central Atlantic Magmatic Province is the Earth's largest, covering some 11 million square kilometres of basalt that formed before Pangaea broke apart near the end of the Triassic and the beginning of the Jurassic period, creating the Atlantic Ocean. Microsoft has detected cyber attacks from Russia and North Korea, targeting 7 prominent pharmaceutical companies researching COVID-19 vaccines and treatments. The targets include vaccine researchers in Canada, France, India, South Korea and the United States. The Microsoft report says the Russian hackers used password spray and brute force login attempts to try and gain access, while the North Korean hackers used spear phishing tactics, sending messages with phony job offers. These latest attacks follow similar attacks by Chinese and Iranian hackers back in May, also targeting COVID-19 research. In July, the US Department of Justice charged 2 Chinese government employees with a raft of computer hacking offences. Well, it's been a busy week in technology, with Apple launching their new Macs powered by the company's new M1 chip. Also just released are the new PlayStation 5 and Xbox Series X. That's if you can get them. And there's been a preview of things to come, with the lines between reality and science fiction being blurred by a new piece of futuristic Israeli technology called Soundbeamer, which apparently does away with normal headphones, beaming audio directly into your head. With all the details, we're once again joined by Alex Zaharov-Reutt from ITWire.com.
Apple launched a new MacBook Air, Mac Mini and MacBook Pro using its own M1 chip. Now, this is a bigger brother to the A-series chips that Apple has used in its iPhones and iPads. But this new chip gives Apple the freedom to develop the main processing and graphical power with its own technology rather than needing to rely on Intel chips, which is the ones found in most PCs running Windows. So the M1 is known as an SoC, a system on a chip. And, Apple has had this system on a chip in its iPhones and iPads for a while, but this integrates the main CPU, the GPU, the graphics processing unit, the storage controller, a bunch of different elements that are normally found on different processors next to the main CPU. But also importantly, this allows the unified memory architecture. That means that instead of the CPU having to copy its workload into memory so that the GPU can read this, which all happens in the blink of an eye. But if you multiply, a blink of an eye a million times, that's a long time. So this allows the architecture to be a lot faster. And, there's been benchmarks that show that the M1 processor is able to run Intel apps, which is one of the things that it can do, faster than the Intel processor itself, which is pretty amazing. So we're talking about up to 3.5 times faster CPU performance, up to 6 times faster graphics performance, and up to 15 times faster machine learning.
Does it come with a portable air conditioner? Or?
Well, the thing is that this enables up to 2 times longer battery life. And on the MacBook Air, which is their least expensive all-in-one computer, there's no fan. If you're doing Zoom conferences and you're normally used to hearing that fan,
in the background,
in the back, you won't have that. Now, look, the Mac Mini and the MacBook Pro do have a thermal system with a fan, and that allows the chip to run even faster. But it's fascinating that the baseline machine, which is more powerful than the previous machine, doesn't need a fan system at all. And so, the other benefit of having a chip that's running on the same ARM technology that the iPhones and iPads are using is that the Mac can now run all of those iPad and iPhone apps natively. It doesn't have to have them translated, it just works.
We've also had a new PlayStation 5 and Xbox Series X come out just in time for Christmas.
Well, if you can get your hands on one. I mean, with these new devices, they're sold out super fast. And already on eBay and Gumtree and those sort of sites, there are people that are trying to sell them for, up to 10 times their price. They sold out in minutes. Apparently, there won't be new stock until next year. I mean, obviously, COVID has slowed down a lot of the manufacturing chains and slowed down logistics, slowed down deliveries. For some people who are desperate to get one for themselves or for their kids, they will pay those higher prices. It's no surprise to see these new consoles, which do promise incredible graphics and a new generation of experience, be extremely popular. It's also important to remember that when companies make their first generation consoles, they're really trying to just get something that's better than what they had with the previous one, but it will be at least a couple of years before the developers really figure out how to stretch the new consoles to their limits to deliver what will really be true next generation gaming experiences. At the moment, they're sort of better than the PlayStation 4 and the previous Xbox, but only by a bit. But over the next few years, they're going to get more and more and more advanced.
Soundbeamer, tell me about it.
Yeah, well, this is from an Israeli company and called Novito Systems. It's like a futuristic replacement for your headphones, and it beams audio directly into your head. Obviously, there's no chip implant needed. And I've heard about such sort of technologies before. We've also had sci-fi talk about this. And this is using 3D sensing technology to have an audio pocket around your ears so that you can hear the sounds in your head. You don't need headphones, and other people won't be able to hear this audio. This way, you won't be hearing the leakage of headphones where other people's headphones are sort of leaking music. And this has to be set up in your home with a special device. This box is sort of sitting there. I guess you can imagine it a bit like a Wi-Fi router.
Does it follow you around the room, or how does it work?
The technology will move around with you wherever you go. So it's just for you. It follows you. It plays what you want inside of your head. Like we've had microphone beaming, and sound beaming is something that's new. There's no prices yet. They're talking about it sometime December of 2021 before this actually becomes something you can purchase, and no doubt it will be expensive. But look, we have to see how good it really is. If you're walking around, or if you're talking to other people, or trying to listen to other things, how practical will this be?
That's Alex Zaharov-Reut from itwire.com. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
We can stop HIV, Iowa. And it all starts with health equity.
We must work together so that all Iowans have access to the resources they need to prevent, diagnose, and treat HIV.
Visit StopHIVIowa.org.